Hi everyone, here is Georgia, and I'd like to thank you for your interest in our Reconstructor software. In today's video, we will have a look on how some specific functions can enrich your way of working on cultural heritage project. Reconstructor has the ability to drape any kind of images, thermal and spherical ones included, both on point cloud and 3D mesh, in order to get a high-resolution 3D model. So, let's get started. When you import a point cloud in Reconstructor that can be structured or unstructured, you can decide to import the color information and the 2D spherical image if available. In the predefined View Drop List toolbox, you can find different navigation modes. Let's select the 2D view one. This function enables to view the selected point cloud in a clever 2D view that represents both the point cloud projection in 2D and the 2D spherical image. There are several actions that you can do here, for example, deleting or duplicating a portion of point cloud or displaying one of the multiple color layers associated to the point cloud itself. To change the color layer visualization, use the drop-down menu available under the point picking option. Depending on the data imported, you can have reflectance and color option, while inclination and confidence are generally created during the post-processing process. If you want to know more, have a look at the dedicated video tutorial. Let me introduce now a nice use of this 2D spherical view. If you have to adjust the color of the scan, perhaps because too dark or too bright, or if you have to prepare a simulation of a restoration operation, you can easily work on this view. Export the view as an image, modify it inside an imaging editing software, and then reapply it to the point cloud. The modifications will be automatically displayed both in 2D and in 3D. In the editing software, you can do what you like, balance white, exposure, change colors, but you have not to change the image dimensions, otherwise the further association will not fit. Once modified the image, go back to Reconstructor and open the color mapping tool that enables to manage, change, delete and create the color layer. Select Add Color Layer and then Add Color Layer from Image. Take the picture previously modified and it will be displayed in the available point cloud layer list. To display the new layer, select in the Property Browser window Color Map and set the new layer created by the image. To colorize a point cloud or a mesh using an external high-resolution image, the first step is calibrating the image onto the model. The calibration process is very simple and consists in positioning the image with respect to the point cloud, finding some homologous point. In the Color toolbox, select the Image and Calibration command. In the drop-down menu, you can find different calibration methodologies. The one we are going to experience now is the camera calibration on a model. The 3D reference model can be a mesh or a point cloud. In the Models box of the window, all the available models are listed. Select the one you want to use and choose Set Reference Model. The point cloud we are going to use a point cloud today will be displayed in the right upper part. Let's move now to select the image to calibrate. On the left, go to Load Image and select the image you want to use. In order to make the homologous point searching and picking faster and smoother, you can use the two little zoom windows. As we mentioned at the beginning, you can calibrate both spherical and perspective images. Go to Settings in order to set which kind of image you have loading. You will see that there are three types of image supported: perspective and spherical, plus fisheye one. Each type of image uses a specific algorithm. Be careful to select the proper image, otherwise the process won't work properly. For each image, you have to choose some common points, 11 in case of perspective and fisheye, and 3 in case of spherical. In this example, we are working on a perspective image, so we have to find 11 homologous points between the point cloud and the image. Once picked, the points will be listed in the two tables on the bottom right side of the windows. What I suggest is taking the points well distributed along the border of the image to calibrate. Once all the points will be picked, select Calibrate and let the software run the process. The average error of the calibration is in pixel and percentage of the image size. Now the image and the 3D model have been calibrated. Click on Make Reprojection to save the calibration image file and to create the projector that will enable to display the image onto the 3D model. Select Save Calibration and go back to the main Reconstructor interface. The projector created is associated to the corresponding point cloud. To look at the result, select it, then right mouse button and load projector. The high-resolution picture will be displayed on the point cloud, and this is what I like most, automatically, also onto the 3D mesh. To load and upload the projectors, you can also use the specific buttons in the toolbox bar, Load Projector and Unload Projector. Let's have a look now how to colorize the point cloud using the calibrated images. In the Color toolbox, select Texture Mapping drop list menu and then Color Clouds with Photos. The Projector Blending for Colorization window will open. You need to select the projectors, you can select how many you desire, and the point cloud to be colorized. Once done, start the colorization process and select Apply as color layer to save the color information from the image as a new color layer in the point cloud. This procedure won't delete the existing color information, of course, it will just add a new color layer. In the Property Browser window, the Color Map option allows you to select the color layer to display on the point cloud. Let's have a look now how to create a texture 3D mesh model. In the Color toolbox bar, select the Texture Mapping drop-down menu. The latest option, Create Texture Map, allows to fix the calibrated images onto the 3D mesh, creating a high-resolution texture model. In the Texture Mapping colorization window, you have to select the projectors. You can select how many projectors you desire, but of course, more they are, longer the process is. And then select Create a single texture map to start calibrating the color information from external image onto 3D mesh. Once it's done, click on the Recluster to generate a new 3D mesh with the color information from the external images. Go back to the main Reconstructor interface. In the project window, you can find the mesh just created. Right-click to load it and check the result. Is it impressive, isn't it? The 3D texture mesh can be exported in different open formats like URL, OBJ, PLY and DAE. In today's video, you would have experienced how to get high-resolution texture models using external images. I'd like to thank you for taking your time to watch today, and as always, I look forward to seeing you next time.